Hello, my name is Alexey Grachov and I'm a senior engineer of CYLAND Media Art Lab. Today I will show our laboratory and show our art pieces that use Arduino. We really frequently use Arduino in our project, and I will try to show you some examples of that for me is fundamental for art purposes as I think. So let's start. The first thing that you need to do when you start to work with Arduino, so it's connected to the computer. Of course, you need to pre-install the Arduino software on your computer and check the latest download that you have. So, and just start it. The basic thing that I always started with, it's a blink. It's a simple blink sketch that you can find here in an Arduino in a sketch and examples in the basics. So you always, so it's the first step that you need to do if you do not know what we'll do later after, and you just choose your board that you connect. For this project I used my old Arduino Uno and select the board. You will see it here, so it's always the same, and just upload it to check that everything works correctly. Yes, so it's blinking and you can check is it right or not. You just changing the delay time and see how the speed of the blinking is changing. So it's the basics. It's a first thing to start. So it's a hello world with Arduino. After, so let's start. So we started with the LED. So let's continue with the LED. I will use the growth examples for the growth board that you must be on your table. But I will use our SparkFun kit and all that it includes, and I will connect it on my breadboard. So you will have a pre-soldered board that you will just need to connect. Here in example it's supposed to be pinlet connected to the pin number 3 of Arduino, and you will need only to connect the cord on your Arduino board on the pin 3 and connect the opposite side of this cable to the small board for LED connection. Here I just already pre-connected it here, so you can find it on my table, or you can find the connection diagram on SparkFun. So I have a book, but you can find it in PDF on the internet, so it's easy. So let's upload it in the same way. So we already choose the board, so we don't need to choose it once again. So it's already connected, and we just upload it. Always check the pin number. So, and all connection. For this connection I used the resistor that was in our kit. It can be a resistor that start from 220 ohm and higher till, I don't know, maybe 1000. It will only depend how bright will be LED. So here the basic example of the analog PWM output. So we can change the brightness of the LED using the pulse width modulation. Pulse width modulation it's a basics for the digital devices. It's easy to explain how it works. I just show you how PWM works. So here's the voltage, here's the time, and in a simple blink example that we just turn on the LED, we just turn on the voltage to the maximum. Maximum for Arduino by default is 5 or 3 volts. So when we just turn it on, so and our LED is working on 5 volts. PWM, it's just small pulses for the 5 volts, and it's just given turn on for a bit for 5 volts, and after it gives a pause and turn it back again and turn it on. So and it's repeats. So the speed here it's really high. So the frequency is about more than 400 hertz. So it can be changed, but for basic it's enough. For example, our lamps, the classical bulbs that we have using 50 hertz speed frequency. Here's 400. So it's the basics. How you can control this way. After you will understand how to control with it different transistors and different kind of equipment. So here's the basics. I can just easily change this connection. Just if I will connect LEDs, I will just add LED and I will show how it will change our setup. Here it's connected that the positive connector of the LED, so it's longer, so it's a plus, this is a minus. It's connected to the Arduino. Now I connect minus of the LED to the Arduino on the same pin or on Arduino, but I will connect the plus of this connector to the plus of the board. Here the connection, the first wire goes to the plus of the LED. After the minus of the LED comes through the resistor to the ground. This connection will be opposite, so I will take the Arduino connection to the minus of the LED and plus of the LED from resistor to the 5 volt, and you will see what it will be the difference. So as you can see, so it works opposite. So it's a basic thing how it can be done. Many analog devices in the past use this kind of the connection to control the current, how the circuit works. So I think this enough for the basic understanding how does the PWM modulation works on Arduino. Here you can change the speed or the maximum brightness. In this loop that you can find in the code, the speed changed with the delay function that you can find here. And also with this you can change this step here, how fast it will the brightness will grow up or grow down. You just make it faster using the so we just change it faster. It's simple mathematics. Okay, so let's add some more components to our board. I will for this example I will use the example from the it will be analog output, and it will be write analog input, and it will write analog output to these LEDs that we have. So I have a potentiometer here, and you have, it calls for your board, it calls growth rotary angle sensor. So you can use it and connect it to the analog input A O, A0. So I will just build it by myself. I will add it here to the board. I will need some cords to given voltage. So we will need ground connector, we will need 5 volts from the Arduino board, and the middle connector of the potentiometer we will connect to the A0 connection. So done. Now we have it. So let's upload the sketch that I prepared. So it calls analog in out serial, and we will change the analog out pin for pin number 3. Here it's 9, so we're using now the pin number 3. So let's change it for number 3. It's easy. So let's check. So it's uploading. So let's check our. So as you can see, when I rotating the potentiometer, it changing the brightness of the LED. The circuit works that it takes the voltage from this potentiometer, so difference of the voltage, and send it directly to the LED. We use the same connection of these two LEDs. It means that the 0 on the 0 volt on the potentiometer means for one LED it means same 0 volts. For another one it means 5 volts. Sorry for the connection. It always happens when you're working on the breadboard. And you should always keep it in mind that something can be connected not good. It's frustrating sometimes. Okay, so it's a basic interaction with the world. Now we have information from the world, and we can change it any time. So for it will give you many possibilities for the future. So let's for this moment stop here, and in the next example I will show you how to transform this example, and we will change this potentiometer to the photocell that you also have in your growth board. This art piece called Dana, and it was presented in London last year, so we show it there. Here's also this work also use servo motor, and it also work with the light sensor. When the light sensor comes to the, so it's a mirror, and when it see the light more than the threshold level, so it's the servo motor starts to bend the mirror surface. So this is also a way to interact with the something. Here it's the next step after Arduino, because here we did a custom board for this project, but it also used the Arduino code, but it's not a typical Arduino. We use here a small AVR microcontroller to make the board a little bit cheaper and more unique. And also we don't need many connections here, so we have only here 2 analog inputs, one analog input to light sensor and another analog input to set the threshold level for the light, and the analog output to control the servo motor. So For me, it's one of my favorite work, and it's also really simple when you understand how you can connect the things together. Let's continue. Let's change this potentiometer, that's variable, also known as variable resistor. Let's change it with the photocell and 10 kilo ohm resistor. So you also have it pre-soldered on your small board, and you just need to connect it to the analog input. So, as you can see, we see two LEDs here. So the same LEDs, the same scheme that we have. But if I will close the light, so the one start to goes more bright, and another one is more dark. So that's how it works. As you can see now, this one is brighter, another one is darker. That's how you can also interact with the space. You can control ambience, or I don't know, in different kind of the ways. I think it's enough to understand how analog input works. And let's continue with the servo motor. The latest project that we made, this tracking eyeballs. It's moving with the 4 servo motor that controls with Arduino, and I will show you how to work with the servo motors later. Here we also use the Raspberry Pi that track movement on the image using the modified webcam camera, and send the coordinates to Arduino, and after Arduino interpreted it to the serial commands. Also, we use the 3D printer to print the holders for the servo motors, and with this artwork you can see that you can use servo motors in a absolutely different kind of the way, and build the complex system using on just the basic principles of the servo motor library of Arduino. And later I will explain you how to work with the servo motor and build the simple schematic simple connection. The easiest way to interact with the physical world is to use a motor. The easiest motor to connection, it's a servo motor, because servo motor, it's motor regular, usually it's a regular DC motor that has a controller in it, and it also has a potentiometer that we use for the analog input. That return the position of the shaft back to the microcontroller in it. So for control this motor, you just only need 3 wires. It's ground, it's a power 5-volt pin, and the controller pin. To control it, we will use the Grow servo example that you also have, and it's servo now we connected for the same pin as the LED, so you can see that the LED is still working, so it's fine for the Arduino to drive up to 5 LED through one pin. And now it's connected to the same scheme that we did. So we still have the photocell that sends the voltage for analog input, and we control the position of the servo motor, the angle of it with the photocell. So when you can see how it works. So I'm blocking the light for the photocell, and it turns the servo. So now you can use the finding things with the servo motor. So it's really easy to use. Also, you can connect back the potentiometer. So as you can see, the servo motor now is shaking a little bit. it happens because we leave the input, analog input, unconnected. So now it has a noise on it. So and it just transmits the noises from the atmosphere, from the surround space to the servo motor. So you can use it. So it's a glitch, and you can use it also if you want. But now we will connect back the resistor transformer, and now we can change also brightness of the LED a little bit. But main thing that we can change with the transformer the angle of the servo motor. For me, all these examples that I show you, it's basics that it's like a fundamental thing for the art purposes, or not also for the art, because in a different kind of the composition, so you can compose different kind of the connection and have a million different variations of system, and systems can be really complex. I think it's enough for the beginning, and for the end I will just, so let's play the song on the buzzer. You also have an example here. It calls grow buzzer, and let's upload it and listen what happens here. And remember all kinds of the things. So it's digital input, analog output, analog input, and all kind of these things using a delay function. Delay is also a fundamental structure for the Arduino. I hope that we will see you soon, and I will explain and show you how to work with all these kind of the wires. And I wish you good luck and have really good experience during your master class. So cheers. One of the complex systems that we built for now, this is a motor structure that we built for our St. Petersburg artist Alexander Shipkin-Hokusai. So this system controls 8 motors on one Arduino Mega. We control the feedback from each motors, and we can record the sequence for the each wing, so we can control each motor independent from another. We're recording it, and after we will play this sequence using MIDI protocol with Raspberry Pi. I hope all that you see today will impress you for your art kind, for building art kind, well, not maybe art kind, to build things using Arduino. And I hope you will enjoy it like I enjoy it every day that I work with. Bye.